All right. Hi, everyone. My name is Liz, and I work for Rise Above Colorado. Rise Above Colorado is a nonprofit based in Broomfield. Our work is really around youth engagement across the state and um, correcting misperceptions about youth substance use. So you maybe have seen our Instagram before or some of our amazing mural projects that we do with youth and communities across the state. And today we're going to be talking to you about data. So my job with Rise Above is I am the manager of communications and community partnership, which is related to our community work across the state. And my colleague Stasi will now introduce herself.
Thanks, Liz. My name is Stasi, and I have been a youth partner with Rise Above Colorado for 4 years now. Today, we're going to be talking about data and trying to understand it and how to think critically about it. I found in my work that this is a really important topic to be able to understand and to explain to others. And I also recognize that it's not something that a lot of people, even adults, have a good understanding about.
Exactly. And that's our hope today, is to just increase some of your skills and understanding around data, both when you look at data that has been collected, as well as possibly going out to collect your own data. So that being said, what is data? How would you define data? Or have you seen examples of data? All answers are correct here. And I'll just add as well that if you'd like to pause this recording and just write down a couple examples, then that's great.
Yeah, so when I was thinking about this, I wanted to look up the actual dictionary definition. And so one of the definitions from the Merriam-Webster dictionary is that data is factual information such as measurements or statistics used as a basis for reasoning, discussion, or calculation. I see data as things that are quantified into numbers, especially from experiments or surveys, and used to provide evidence to make a point, for example, bolstering an argument or a proposal.
Exactly. Beautiful. And I'll just add in addition to that, you've probably participated in surveys like the Healthy Kids Colorado survey before, or you know folks who have, and that is an example of data as well.
Alrighty, to start us off, we wanted to do an activity. If we were doing this live, we would have you all doing a sample worksheet of your own, but you are welcome to follow along and answer the questions as we go. Or if you're with a group, you can do this on your own or do this together. When looking at data, and in particular presenting it to new audiences, a common pushback is that statements like most youth don't drink on a regular basis couldn't possibly be accurate. The reasons vary, but one specific one is that people lie on surveys. A fair response is that the structure of the survey and the sample size eliminates the likelihood that people who are lying will make a significant impact on the results. However, that is often a difficult concept for people to understand. So we wanted to do a little activity to help understand that. This activity is designed to give you an idea of why sample size matters and also help you recognize that a study needs to have a high enough sample size to eliminate errors like lying and from having a significant impact on the numbers. Alrighty. So here on the worksheet, we are answering the question, do you have siblings? And so on the left, we have a pair of 2. And I should also say that for this activity, before we begin in a whole group, we choose one person to be our representative liar someone who is going to answer the question inaccurately so that we can later compare the results between if somebody's lying in the group and what the results would be if they're telling the truth. So in these pieces, one of the people is lying in the group. So in a pair, we have both people answering yes, they do have siblings. And so 2 people answering yes out of a total number of 2 is 100%. Then we have 2 pairs get together to make a group of 4. And in this group of 4, all 4 people answered yes, and that also gave us a percentage of 100. And then we had a whole group to come together with a total of 20, and 18 people responded yes, they do have siblings, which gave us a total percentage of 90%. Alrighty, so between rounds, if your numbers remained the same, what can we say about this? And again, feel free to pause the video if you would like to consider this on your own.
Yeah, I would say, you know, in that series, it seems like maybe you could assume if the numbers stayed generally the same, that a pair was generally representative of the whole group.
Yeah, thank you. And on the other side of that, if your numbers changed, what can we say about that?
So yeah, maybe an answer or a thought would be just that if the numbers are quite different, maybe a pair, the response from a pair isn't accurate or representative of the entire group.
Definitely. Yeah, thank you. So one way that could show up is if you have a friend group, that's a small representative of, like, say, the whole state. And so that may result in a higher or lower percentage of whatever's being measured compared to the whole population. And then lastly, which percentage did you say you believed more and why?
I would guess that I'd probably believe the large group percentage more, just because more people were asked, you get a wider variety of answers.
Okay, thank you. Alrighty, so at this point, we would have our representative liar reveal themselves to the group so that and ask them to answer honestly so that we can compare the differences in sample sizes and responses. So in a pair on the left side of the screen, the person lying had originally answered yes, which gave us 2, but in reality they do not have a sibling, and so their answer was no, which changed our percentage from 100% to 50%. In our group of 4, this lying changed our answer from a total of 4 saying yes to a total of 3 saying yes and 1 saying no, which gave us a percentage of 75. And in our compared to 100%. And in our group of 20, our large group, we went from 18 saying yes to 17 saying yes, and from 2 saying no to 3 saying no, which changed our percentages from 90% to actually being 85%. And so what do you notice about the differences in results at the different sample sizes between someone telling the truth and that person lying?
Yeah, so in the first round, when you have someone telling the truth, it changed by 50%. And then in a group of 4, the change in someone telling the truth only changed by 25%, which is quite a bit lower. But then when you look at the whole group out of 20, the change in percentage is only 5%. So I guess that really kind of shows that the bigger the sample size, the smaller the difference will be if someone isn't being truthful.
Yeah, definitely. Thank you. And so that's kind of our way of showing that as sample size is increasing, the impact of the person lying is going to be less and less significant. And in statistics, that does result in a difference of significant difference to not being significantly different.
Yeah, and that's a question I hear people say a lot related to the Healthy Kids Colorado survey. You know, how can this be truthful? People lie all the time on surveys, but we know that in fact, because of a lot of things that the survey administrators put into place around making it anonymous and formulas that they use, we generally can trust that even when people are occasionally and rarely untruthful, that ultimately the numbers that come out of it are accurate.
Yeah, thank you, Liz. All right, so for our next part, the difference between correlation and causation is something that is very important to understand when looking at data and determining its impact on the issue you're looking at, as well as how some people can skew the understanding of data to make their own point. It is important to be aware of this difference and to look to understand it in any kind of research. The basic premise is, are these two factors simply related somehow, or is one actually causing the other? And fortunately, instead of me sitting here and explaining it, we have a fun video for you to watch. And I'll also say that the other text on this slide is just some extra concepts to think about when looking at data that were on the same website as the video we are going to show.
So I'm going to go ahead and pull up that video now.
Like most people, I enjoy a tasty scoop of ice cream, especially Oreo blizzards. But what few people realize is how dangerous a treat ice cream has become. First, there's the issue of obesity. Second, there are higher crime rates. Third, there's the loss of life due to a rise in the number of drowning deaths. And finally, as more ice cream is sold, there's an increase in forest fires. Given these indisputable facts, I need you to support my vision of an ice cream-free world. While banning ice cream trucks from entering your neighborhood may sound far-fetched, when it comes to problem solving, a common issue is misunderstanding the difference between correlation and causation. This misunderstanding can influence our decisions, sometimes with serious consequences that ripple throughout a community. Correlation is when two things are related, but one does not cause the other. Usually this means the two are in some way related to a third factor, but not always. If you have a big enough pile of data, you can find plenty of relationships that are purely coincidental, like the strong relationship between the sale of margarine and divorce rates in the state of Maine. With the sale of ice cream, the third factor is weather. When it is hot outside, people buy more ice cream. They are more likely to go for a swim, and there is a general increase in people out and about enjoying the weather, helping improve conditions for crime to take place, as well as the dry conditions associated with forest fires. A note of caution: there is a growing trend in our digital world called data dredging. This is using analytics to sift through mountains of data, hoping to find useful relationships. Instead of a problem in search of a solution, dredging data is a solution looking to find a problem. All of what I've just discussed about correlations does not mean that finding a correlation is without value. In fact, correlations are a vital part of helping us move to the next step, the discovery of causation. Unlike correlation, causation is when you can claim that one thing causes another thing to happen. In order to make this claim, you need to be able to demonstrate an actual cause and effect relationship, preferably a strong relationship. An example most of us are familiar with is the pharmaceutical industry. In order to make the claim that a particular drug causes a certain effect, such as lowering your cholesterol or growing hair, the FDA requires companies support those claims, putting the drug through a 4-phase, 12-step process that takes approximately 12 years. This process uses control groups and clinical trials to test the drug, making sure that X causes Y and that the drug is safe. The acceptable error rate can go as high as 5% for some drugs, meaning that the clinical trials prove that there's a 95% chance the drug does what it claims. Drugs with serious health implications, such as those used to treat a heart condition, are held to an even stricter standard, requiring proof up to 99% effectiveness. Back to ice cream. What about ice cream and obesity? While it may seem like common sense that it does cause obesity, the fact is that we don't yet know the true strength of the relationship. If we look at the sale of ice cream, there's actually an inverse relationship with weight. People gain weight in the winter when sales are low and lose weight in the warm summer months when more ice cream is being consumed. This might suggest ice cream is the new diet food. Luckily, you now know to be cautious of drawing conclusions of causation from correlation. Instead, recent research on the subject has been looking at different types of sugars used in making a wide range of sweet foods. What scientists have discovered is that the hypothalamus, which is an area of the brain that regulates the human appetite, reacts differently when we consume foods with fructose instead of glucose. This has researchers speculating that eating high fructose foods, such as ice cream, may result in people not feeling full, so they continue to eat. This theory proves difficult, however, when we start considering apples and other natural fruits also contain fructose, not just ice cream and chocolate cake. As you can see, causation is quite a bit different than correlation. Finding correlations is easy, proving causation is hard. No wonder it takes 12 years just to prove that a pill causes hair to grow. The bottom line, on the news, in boardrooms and coffee shops, everywhere you go, you will hear claims that X causes Y. From politics to the weather, from the stock market to personal relationships, it is human nature to try and explain things, to create stories that make sense. Just keep in mind, as you hear a claim of what causes what, that correlation is not causation.
I love that video.
Me too. It definitely puts it in a different perspective, and it's really catchy to grab your attention at the beginning.
Definitely. All right, so next slide. Now that we have some understanding about the importance of recognizing the difference between correlation and causation and the possible need to dig deeper to understand the full story, I wanted to provide you with some other tips that boil down to simply thinking critically about the data you're looking at. When looking at a study or something that references a study, consider, what could this mean? Is there more data to show other connections? And what can we actually say based on this data versus what's actually speculation? We saw some examples of that in the video. Do they explain how they found this data? If they removed any data or outliers, did they give reasons that seem reasonable to you? Are the sample size and demographics representative? Consider consider how the survey or experiment was conducted. Does this leave gaps for who participated? And could that significantly change the results? As an extreme example, what issues could you see with conducting a solely online survey that asks about people's access to the internet during the pandemic?
Yeah, so that right there immediately, I think if it's an online survey, what if people don't have access to the internet? They won't be able to participate.
Exactly. What could be changed to make that study more reliable and representative?
They could broaden their reach and maybe print out paper versions of the survey, take them to the library or other places where folks might be accessing the internet outside of their home or school.
Great ideas, thank you. Alrighty, here's some more tips that are even more general for looking up sources to support your argument or your work. 1, do they cite their sources or link to them? If you can't figure out where they got the information they're reporting, that's suspicious and could mean it's inaccurate. 2, can you fairly easily find who funds them? Funding sources gives you an idea of how they might be biased in talking about a topic related to their funders or not mentioning bad things about that funding source. If they mention their funders in the article or the video, that's even better. This may be showing that they are openly acknowledging the inherent bias of having a funding source related to that topic, and hopefully means they try to minimize bias in how they talk about the issue and try to be as fair as possible. 3, look up writers for bias. Look at the source writers of the study or whatever it is and determine qualifications for speaking on the topic. If there's a source used in an article or video, try to look up the author of that source and see what credentials they have and what they've worked on in the past. This will give you an idea if they are qualified to speak on this topic or if they did the research. Look at other works of the writer for the piece that you're reading or watching. Look at the other works of a writer. Looking at the other works of a writer gives you an idea of what biases they might have and can help you evaluate this work critically. 4, is this news source known to be biased in some way by the community? This doesn't mean that you can't use them or shouldn't look at their information, but it does mean that you should be critical of the source, keep that bias in the back of your mind, and look for evidence of that bias when reading. And 5, be even more critical of the sources that you like. When we see information we agree with, it's easy to just say, yep, that sounds right, and move on. This is sometimes known as confirmation bias and basically means that we are inherently more critical of things we don't agree with and less critical of things we do agree with. So essentially, I'm saying be as critical of a source you like as one that you don't. Alrighty, so I want to briefly explain what RACYS is. Again, Rise Above Colorado is our organization, and every 2 years we conduct a survey of youth in Colorado that is complementary to the Healthy Kids Colorado survey. It is called Rise Above Colorado Youth Survey, or RACYS for short. Before we transition to our next point, I wanted to circle back to thinking about causation versus correlation and how to use data to take action on something you care about. With this last round of RACYS data, a correlation was found that youth who are on social media 5+ hours a day are much more likely to have reported 6+ poor mental health days. Rise Above Colorado wanted to make it clear in our infographics that this was a correlation, not causation, because the connection between these two is complicated and the data is currently inconclusive. For instance, they don't want people to be trying to say that teens being on social media is causing an increase in poor mental health days, because that is not an accurate interpretation of our data that we collected. However, if a group was trying to, say, address mental health issues, they could look at this data and use it to say that oftentimes youth who experience poor mental health are also on social media more. And this means that social media is a perfect outlet to be reaching out to our peers who are in need by sharing mental health resources and encouraging them.
That's a super important consideration. So we wanted to also discuss visual representations of data because they can be really powerful and they can be misleading. So I wanted to share this exercise that was brought to us by one of our fellow Rise Above colleagues that they learned in a statistics class taught by Dr. Cynthia Erickson. Not sure where this exercise originally came from. It might have come from them, so wanted to give credit there. But let's say that we wanted to study the effect of candy on happiness. This is an exercise you could do with folks. We'll just talk hypothetically today. So let's say that you give a group of people 3 different kinds of candy randomly: gummy bears, M&Ms, and Kit Kats. And then you ask them to rate how happy they are in that given moment. And then you chart it on a graph. Looking at this graph, what do you think this tells us about the relationship between candy and happiness?
Yeah, so to me, the visual is making it look like there's a huge difference between gummy bears and M&Ms versus Kit Kats affecting happiness.
Yeah, definitely. Looks like a huge difference. So when we look at these 2 graphs side by side, these are taken from the same information, same ratings on happiness. So when you look at these 2 different graphs, what kind of conclusions can you make now?
Yeah, on the right, it looks like there's just about no difference between the type of candy the people got and how happy they were. And I noticed that on the right, the scale goes from 0 to 10, which is how you're supposed to represent data in general. Whereas the graph on the left is only showing numbers of 9 through 10. So a difference of 1.
Yeah, exactly. So first glance, it seems like a really significant difference, but when you look more critically at the graph, you can see that it wasn't charted in a way that's fair and accurate to show by only showing the difference between a 9 and a 10 on the happiness scale. If you're eating candy, you're going to be happy more or less. So obviously a more accurate way to show that is on a scale of 0 to 10, because that's the scale that you asked your sample to rate. So it's important to think about when talking about data. You may have heard the term statistical significance, and that is actually a formula that researchers use to understand in data if there was a meaningful change or if any change was just coincidental or circumstantial. So that's really important to think about and is I would say maybe a more advanced next step with understanding data, but is just an important factor to think about. Just because it looks like there's a change, or maybe the percentage seems like a big change, it may not be. Sample size might have changed considerably, or there might have been a huge event on a given day that affected people's responses. So we also wanted to talk a little further about the implications of data and decided to use a survey you may be familiar with, the Healthy Kids Colorado survey. And this is some demographic information from the survey in 2019. So we wanted to give consideration to different demographic groups within the survey, especially because gender identity is a newer demographic question that hasn't historically been asked in the past, but has a lot of implications for the work that many of us do in improving the health of all youth across Colorado. So you can see quite a difference in percentage and sample size here based on all youth participants who took the survey. I I should add as well that we are just discussing suicide, and that is and can be a trigger for folks. So throughout this conversation, if you need to pause the recording or reach out to someone you trust, or even the Colorado Crisis Line, please do so. We want to, increase awareness and discussion and reduce the stigma around suicide, but we also want to be super careful and recognize that folks may have a variety of reactions to this conversation. So when you look at the percentage of youth, so on the bottom of this slide here where it's in orange, that's the total number of youth who took this survey that said they had seriously considered attempting suicide in the last 12 months. So 17.5% of all respondents said yes, they had seriously considered suicide. We wanted to pull out a few demographic breakdowns to just show that just looking at that total number doesn't give us the whole picture of the youth experience in Colorado. So when you look at the respondents next to students who identify as bisexual and gay or lesbian, the number is quite higher than those who identify as heterosexual. So out of the students who identify as bisexual, 44.1% of those students said yes, they had seriously considered attempting suicide, and 35.3% of students identifying as gay or lesbian said they had considered attempting suicide. And just to compare, the students who identify as heterosexual said 13.4% of those students said they had seriously considered attempting suicide. That is we can make assumptions about that difference. That's quite a sizable difference in experience. And then I also wanted to call attention to the number of students who are identify as transgender, being, my taskbar got in the way, 51.5% of students identifying as transgender, so over half. It's a sizable difference, and it's important to consider because we need to think about the experience of all youth in Colorado. Another thing to consider when looking at data is the importance of percentages in a population rather than the number themselves. So the percentage, of a population is going to give you a much more accurate representation, while looking at this demographic chart, let's say 1.3% of students who took the survey identified as transgender. However, 51.5% of those students, their experience was much different than the greater population of participants. So it really can help you target your work to consider just a variety of experiences of youth. Another thing I wanted to just share is that when you look at data, it can really help remove the personal values people attach to issues they don't agree with. It can help you have better conversations that are based on data and based on fact versus assumption. Because people often will pull out a singular data point and try and prove a point related to their agenda around racism, homophobia, ableism, any kind of ism or phobia you can think of. So it's just really important to consider all these factors when looking at data. And then we wanted to pull out a snapshot from our Rise Above Colorado Youth Survey similarly related to youth who identify as LGBTQ+ in Colorado. So it's important to consider that there are probably many reasons why youth in this community may experience higher rates of suicidal ideation, but this sort of summary talks about that often it has something to do with your sense of belonging or your opportunity for safe spaces to be exactly who you are. And as prevention professionals or folks who work in healthcare, this is super important and has a lot of impact on the work that we do. And we need to be asking these questions. I wanted to give an acknowledgement to Envision You. Envision You helped us with our verbiage around our Rise Above Colorado Youth Survey and talking about the implications of data and how often youth who are LGBTQ+ may be experiencing higher mental health distress. And if you haven't heard of Envision You should check them out. They're incredible. They really work exclusively on that intersection of LGBTQ+ youth in Colorado and mental health and substance use. So finally, as a wrap up, we would just encourage you to pause this recording and think about this on your own. How can you use the information from this session to help you learn more about issues in your organization? What new information or considerations came up for you during this session? And if you are looking for some resources or hope to collect data of your own for a project, we do have a list of resources for you to check out in our facilitator guide that accompanies this presentation. After further ado, thank you so much for joining us today and spending time going through this presentation with us. If you have feedback or questions, please reach out to us.
Yes, thank you all so much. And also, if you are interested in presenting this yourself to another group, we have a facilitator's guide and slides that you are welcome to use. Thank you all.
Great, thank you.